All right, so just jumping into central limit theorem. So we sort of need to point out this section we've previously done, which is if we have a random variable and it has a mean of mu and standard deviation sigma, we can consider multiple trials of this variable. So S of n here is the sum of all those observations, which we've sort of covered this. So this is the distribution if you added these values together. And we find that the mean of this is the number of trials times the mean of our original observation. The standard deviation of this is the standard deviation of our original random variable times the square root of the random number of trials. Our next one is the mean of these observations. So this means sort of if you were taking these samples, you would be doing the mean of each distribution or like possible means that you could be getting. So the mean of these observations, which we've covered, and this one means the mean of this, I'm trying to think of the right way to say this. We're looking at the mean of this average distribution. I'll call it the average distribution so we can talk about the mean of it. Is just the mean of the normal one. And the standard deviation equals the standard deviation over the number of trials, the square root of the number of trials. Now, we've actually done this previously, hence I've rushed over that. Now, with the central limit theorem, I've just summarized it here. There are online resources which we can talk about, but it really helps us when we want to consider probabilities. And so some of these things, previously we've only been able to calculate probabilities of a random variable by either knowing all the data or if we have a normal distribution. Now, when we moved x to a continuous distribution, we had some different functions that we could have. But this central limit theorem, what it actually means is if we have a little bit of information, so if we end up with, we've got this random variable and it's not normally distributed and it has a mean and a standard deviation, what we can actually do is we can take a sufficiently large number of trials, so we can do this variable either, a certain amount of times, and these two sampling distributions up here will become normally distributed with a mean and standard deviation as stated above. So that means that these rules means that we can actually consider these things, these distributions as normal, as long as we have a sufficiently large number of trials here. So the rule of thumb is the number of trials is greater than or equal to 30, but if your original distribution is close to being normally distributed, that could be less. If it's really far from being normally distributed, it could be more. If observations are without replacement, n must be small compared to the size of the population. So that means if you're taking from something, you need a really small number of trials compared to the population. The idea behind that is if you think about if we had if our random variable was like, 5 balls in a pot, if you remove one, you've removed 20% of the population. If that's without replacement. So we need each trial to be independent, so n must be really small so you can't really notice it. If this is normally distributed when we start, the sample distributions are always normally distributed. So I'm going to go into an example now, and then we can sort of deal with this later. So a random variable x has a mean 60 and a standard deviation 4. A sample size 45 is taken from x. Find the probability that the mean of the sample is less than 59. So we're looking at this here. We're given values here. So we're looking at x has a mean of 60 and a standard deviation equal to 4. Now, it doesn't say it's normally distributed, so we have to use central limit theorem here. And so what we do here is we're considering, we're going to be considering a sampling distribution. Now, the key bit here, let me get my highlighter, is find that the mean of the sample is less than 59, the probability that the mean of the sample. So that means we're going to this distribution up here, we're going to this xn one because it is the distribution of means. And so in this here, we're going to be looking at, x dash, and we're looking at a sample size of 45 is taken, which means we're looking at 45 trials of this random variable. And because of this, we can sort of, so this sort of represents, so I'm just going to go, this is n equals 45. And then if we remember our rules up there, the mean of this, of 45, that's getting a bit messy. The mean of the distributions, so the mean of this distribution here is just going to be this mean here. That was our rule, which we worked out. We covered in distribution of sample means. And then our standard deviation of this mean distribution is going to be equal to the standard deviation. So we're going to be looking here at the standard deviation over the number of trials, the square root of the number of trials. So our standard deviation here is 4. And then we've got over square root 45, which I'm just going to simplify now to be 4 over square root 9 and square root 5, which means we're looking at 4 over 3 root 5. Now, I'm only doing that in case I was doing an exact thing. We're not in this particular one. So we're now looking at this is a new random variable of sample means. It is normally distributed because we're over 30 trials. And we can assume it's normal, and the number of trials is going to be, the mean of this distribution is 60, and our standard deviation here is going to be, I should have just left it because I'm just going to write it in here, 4 over square root 45 and that is squared just when we write the distribution. So now we're going to calculate the probability. So what are we doing? Find the probability of the sample, that the mean of the sample is less than 59. So we're looking at the probability that our sample mean, once we do 45 trials, is less than, well, that's not a very good less than, is less than 59. So less than 59. Now, I'm just going to write this out as my NCD, just because this should help us with a solution. So we're looking at as negative as we can go, up to 59. And then because we're using the Casio, remember it is, I'm just going to quickly double check I've got it right. The Casio is lower, upper, and then it's the standard deviation, which we've got is 4 over square root 45. And we're looking at a mean of 60. And when we put that in, let me just type the values into the calculator, 4 over square root 45. And then we've got -1 up to 59. So we end up with, this is approximately equal to 0.0468, and that's to 3 significant figures. All right, and that's our answer there for that one there. So that's just an example question. Jump into these, have a get. These questions are in 9C, but jump in it and have a go through them. Thanks, guys.